Okay, first we're going to talk about ionization energy. Ionization energy is the energy required to remove the first valence electron from an atom when it is in the gas phase. Coulombic force is holding the valence electrons to the atom, so this means that ionization energy is acting against the Coulombic force to remove them. The ionization energy is the same as the Coulombic force, but in the opposite direction. If an atom has a high Coulombic force, it means the valence electrons are held tightly to the nucleus and therefore means it requires a lot of ionization energy to remove it. As you go down a group, the trend is for ionization energy to decrease. The reason for this is as you go down, the valence electrons are further away from the nucleus, which means they have less Coulombic force pulling them in, and this makes it easier to remove the electrons because they aren't held as tightly. As you go across the period this way, the trend is for ionization energy to increase. The reason for this is that the valence electrons are in the same energy level. So as you add electrons to the outer shell, the nuclear charge increases. This means that there's more Coulombic force pulling them into the nucleus and they're held very tightly. Therefore, it will require more energy to remove them. There are two exceptions to the ionization energy rules. The first one is beryllium and boron. Here's beryllium and here is boron. And as you know, as you go across the period, the trend is for the ionization energy to increase, but in this particular instance, the ionization energy decreases. The reason for this is that beryllium has its valence electrons in the s orbital, and boron has its valence electrons in the p orbital. The p orbital is very slightly further away from the nucleus than the s orbital, and therefore is less Coulombic force pulling it in and less ionization energy needed to remove it. And this also works for magnesium and aluminum, and as you go down. And the other trend is nitrogen and oxygen. Here's nitrogen, and here is oxygen. And the trend over here is to decrease as well, which is against the general trend as you go across. Nitrogen has one valence electron in each p orbital, and oxygen has 4 valence electrons in the p orbitals. This means that the fourth electron has to double up in one of the orbitals, and when you have these two electrons in the same orbital, they repel against each other. This causes oxygen to be slightly further away from the nucleus and therefore requires less ionization energy. This is also called electron-electron repulsion in the orbital, which moves it further away, and therefore there's less Coulombic force. And that's it.